Okay, so to get started, we are going to review solving quadratics. Remember, this is something you've already learned. This is just a quick review of it. You will need it all year this year. So on your notes, you can see the main two different ways we use to solve quadratics. There is a third way, the completing the square method, but mostly we like to use factoring and zero product property when possible. So when the answers come out to be rational, factoring and zero product property will work. And if not, quadratic formula, that one will always work, whether they're rational, irrational, or even imaginary. Your quadratic formula will always give you the answer, and there's your formula right there. So we want you to solve x squared minus 5x minus 14 equals 0 using the two different methods. So why don't you try factoring that, see if you can remember how to factor, and then do zero product property, and then pause your video, and when you unpause it, you'll be able to check your answer with mine. So first try factoring and zero product property. Pause your video. Okay, I didn't quite finish it in case you needed a review. So factoring, make your area diagram, x squared in the bottom left, negative 14 in the top right. You multiply those together, that's where negative 14x squared came from in the top of my diamond, and the middle term, negative 5x at the bottom. So what two numbers multiply to be negative 14x squared and add to be negative 5x? So that would be negative 7x times 2x makes negative 14x squared, and when I add those together, I get the negative 5x that's necessary. Remember, those answers go inside your empty boxes. Then if you look at the first column, GCF, those both have an x. This must be x in order to get x squared. X times this must be negative 7 will give me negative 7x. And negative 7 times 2 will give me the negative 14. So factored, x minus 7 times x plus 2 still equals 0 because the problem equaled 0. Then zero product property, we wouldn't expect to see this, but I'm going to show it this one time. Set that factor equal to 0, get an answer. Set the other factor equal to 0 and get your answer. Those are our two answers for this quadratic equation, but the question wants you to solve it two different ways. So now try quadratic formula and make sure you get the same answer, right? We're solving the same question, just two different ways. We better get the same answer. Pause your video and try quadratic formula. Okay, I am showing one more step than I normally would. Literally just plugging in a equals 1, b equals negative 5, and c equals negative 14 straight into the quadratic formula, making sure to use parentheses every time I plug a number in. Normally, though, I would jump to the next step. So when I do negative 5, I just write it down as 5. I know that that's going to be 5. Plus or minus. Also, I can square 5 or negative 5 in my head. The point is, though, I always get a positive number. If you don't know 4 times 14 is 56, I have negative times another negative, which is going to make that plus. Sorry, did I say 56? Yeah, plus 56. And then all over 2 times 1 is 2. So normally this is the step I do. I do a lot of that math in my head. If you pick up a calculator and you square negative 5, if you don't use parentheses correctly, your calculator is going to tell you it's negative 25. So you need to pay attention. The first number under the square root always comes out to be a positive number. Okay, then simplify. 5 plus or minus the square root of 81 over 2, which is 5 plus 9 divided by 2, and 5 minus 9 divided by 2, which gives me 14 over 2, which is 7, negative 4 over 2, which is negative 2, which are the same two answers that we got earlier because we solved the same problem two different ways. Okay, continuing on with our review, factoring. There are 3 problems there for you to factor. Remember, when you're factoring, you always start, it doesn't matter how many terms there are, you always start by looking for the GCF. So let's do that for all of these together before we even get started. So when I look at the 2 terms, and it's important to know that A is 2 terms, which should make it a little easier to factor. X squared and negative 81 have nothing in common, so they do not have a GCF. I'm going to come back to A in a minute. Let's finish doing GCF. First thing you always do, because the directions imply that you're going to factor it completely, is look for the GCF. Look at these three terms. What can you factor out of those three terms? So hopefully you recognize they're all even, so you can factor a 2 out. The 2 does not disappear. It gets written in front. If that 2 disappeared right now, you'd already be down to 66% for the grade on this one. The 2 does not disappear. It gets pulled out front, factored out front. When I divide by 2, I get x squared. When I divide by 2, I get 5x. And when I divide by 2, I get 6. When I come back to this, I'm going to continue factoring this piece. Let's finish GCF before we forget, though. One of the things you always want to do, when the first term is negative, you should factor that negative out. It just makes it easier. I'm a math teacher, and that's what I do every single time to make it easier. You always want to make the problem easier. So as I'm looking for the GCF, 4, 10, 6, hopefully you see those are all even, so you can factor out a 2. But because that first term is negative, factor out negative 2. So see if you can factor negative 2 out. Remember, it's written in front, does not disappear. What do you get when you divide each piece by negative 2? Divide by negative 2, now it's positive 2x squared. Divide by negative 2, now it's positive 5x. Divide 6 by negative 2, and now it's minus 3. What we have left here is so much easier to factor now that the first term is positive. Sorry, we made it positive. Okay, let's go back and finish A. So A is 2 terms. I see that that's squared, x is squared, and 81 is a perfect square. You should recognize this as a difference of squares problem. Difference of squares has a nice little formula. A squared minus b squared has to be what your question looks like. 2 perfect squares with a minus in the middle, that's the difference. It factors to b. Square root of a squared is just a. Square root of b squared is just b. 1 with a plus sign and 1 with a minus sign. This should be looking familiar. I'm not teaching this to you for the first time. You've seen this before. So square root of x squared is just x. Square root of 81 is just 9. 1 with a plus, 1 with a minus. Don't forget it's 2 different factors, 1 with a plus and 1 with a minus. That one is now factored completely. B, we are only looking at the inside. I'm going to leave some space and I'm going to bring this 2 down. Don't forget the 2. And then we are going to factor the parts in yellow, just like we did on the zero product property problem earlier. So if you need some help, you can follow along. Otherwise, just skip forward a few seconds and get to the answer. Make your area diagram, make your diamond. X squared, 6. X squared times 6 is 6x squared. Middle term on the bottom. What multiplies to be 6x squared and adds to be 5x, 3x, and 2x. Those go in the boxes. It doesn't matter which one you put them in, but if you're following along with me, use the same boxes as me. So this must be x times x. That's how I get x squared. So this must be 3, and this must be 2. X plus 3, x plus 2, with the 2 in the very front is our answer. Remember, only 66% if you forget that 2. Do not forget the GCF. Last one, I'm going to change colors so you can follow along. I'm going to need some space, so I'm going to bring my negative 2 down here. You can make your area diagram and go ahead. (2x squared) negative 3, 2x squared times negative 3, negative 6x squared, middle term, multiplies to be negative 6x squared, adds to be 5x, must be 6x and negative 1x, 6x, negative x. So this column here, they both are divisible by 2, so the 2x goes on the bottom based on the way I set it up. So x must be here, so 2x times this must be 3, and 3 times this must be negative 1. So the GCF of negative 2 times x plus 3 times 2x minus 1. Also the same thing as writing it this way, As long as the numbers in the parentheses don't change, either one of those is perfectly fine for your answer, factored completely with the GCF in front. Okay, moving on in our review, points of intersection. Use any method to determine the points of intersection of those two equations. So first thing you want to notice is, in this case, they both are equal to y. If they both equal y, then they both must equal each other. So substitution. X plus 2 squared must equal negative 2x minus 4. Remember, you cannot distribute a square. That is not how math works. What that means is x plus 2 times another x plus 2 still equals this side. You could make yourself a little area diagram to help you out with that x plus 2 times x plus 2. Really important that you don't forget what happens in the middle. It is not x squared plus 4. It's x plus 2 times x plus 2, which there's the x squared plus 4, but I also get a 2x here and a 2x here. So that whole thing ends up being x squared plus 4x plus 4. Do not forget how to multiply binomials or square binomials. Okay, now I've got x's on both sides. That's not helpful. Let's move all the x's to the same side, and whenever possible, keep your x squared positive. So let's move everything that direction. Now I've got x squared plus 6x plus 8 equals 0. What do you know? It's a quadratic. We just reviewed 2 different ways to solve quadratics. Why don't you pick your favorite one and solve this quadratic? Pause your video and come up with your 2 answers for x. Okay, so I showed my factoring, but I'm going to move on past that. Hopefully you got x equaled negative 4 and x equaled negative 2. Remember the question said point of intersection. When you solve a system that has x's and y's, your solutions need to be x's and y's. So you need to take your 2 answers up here, one at a time, and plug them in. You can use either equation. I think the second equation is easiest. So my second equation is negative 2x minus 4, just taking that from the problem. Let's plug in x equals negative 4 and see what what y value that x gives us. So into my y equation, I'm plugging in negative 4. That gives me a y value of positive 4. So one point is negative 4, 4. Do the same thing with your other x value. That gives me y equals 0. So the other point of intersection is negative 2, 0. These are our 2 points of intersection for this system. This is a parabola and a line. This is not what it looks like at all, but there's my parabola and there's my line. It hits twice, so you got 2 points of intersection for your solution. Okay, moving on to our final review for this video, reviewing functions and function notation. So we gave you a function, f of x, 3 minus x squared, and we want you to calculate those 2 different things. This is like 2 problems in one. So I am going to do f of 5. Remember, when you see the parentheses, you say the word of, so that is read f of 5. It means take equation f, and where you see an x, use parentheses and plug in 5. This is 3 minus 5 squared is 25. This gives me negative 22 for this answer. I'm going to call it, I don't know, part B, f of 3a. Still means the same thing. Take equation f, 3 minus, but when I see x, I'm going to use parentheses and plug in 3a. Do a little bit of simplifying. 3 minus 3a squared is 9a squared. This is numbers and letters. I can't combine any more like terms, so that's the answer. See if you can do the first part of B. Pause your video and see if you can do the first part of B carefully. Careful, because there's a squared and a negative involved. Okay, how'd you do? 5 minus 3 parentheses negative 2 squared. You square the negative 2 first, and it gives you positive 4 times 3 is 12. So you're really doing 5 minus 12, so you should have gotten an answer of negative 7. G of a plus 2. So now we're plugging in a little expression here. So 5 minus 3 times, instead of x, I'm plugging in a plus 2 squared. Remember, I talked about how you cannot distribute a square when there's a plus sign. What do you need to do? You need to write it out as 5 minus 3. This doesn't change. A plus 2 times A plus 2. So maybe you need to draw yourself a little area diagram. I'm not going to. I don't need to, plus I'm running out of space. But if you carefully draw the area diagram that I've done earlier on the same video, you end up getting a squared plus 4a plus 4. Then you can carefully distribute the negative 3. I'm going to write up here now. 5 minus 3a squared, negative 3 times 4, minus 12a, negative 3 times 4, minus 12. And then finally I can combine like terms. Negative 3a squared minus 12, 5 minus 12 is minus 7. So, function notation, carefully plugging it in using parentheses and then neatening it up a little bit. Okay, nothing new in C. Go ahead and try C. See if you get the same answer as me. Pause your video and complete part C. I said nothing new, but I guess technically having 2 x's is new. So hopefully you plugged the 2 into both x's using parentheses. Neaten it up and you get negative 5. D is completely different. Look at D and figure out what's different in D. So instead of being the number in the parentheses, we gave you the number it's equal to. So you take your equation and set it equal to that number. Notice the difference. In the parentheses, plug it in, equal to the number, set it equal. And here we are again. You've got a quadratic that equals 0. We've gone over this a few times now. You can do factoring and zero product property if you like, or quadratic formula will always work. Pause your video and see if you can get your answers. I'm not even going to show my work for this. I want you guys to try it on your own. Pause the video and then unpause it to see if you got it right or not. Okay, there are my answers. X equals negative 3 and x equals negative 2. How'd you do? Quadratic formula or factoring and zero product property should have worked on this. Also, notice I got 2 answers for x. When they give me what it equals, the number that it equals, I am finding x. Last page, I believe. Yes, okay. Setting it equal again. This is the slides where they equal the number. See if you can solve E and F, set the equation equal to that number, and then solve for x. Try E and pause your video. Okay, hopefully before you got too far, I know I've been preaching about you cannot square a parentheses, you can't distribute a square, but you don't even want to do that. You want to make the left side more simple, right? So instead of trying to do x minus 5 times x minus 5 and then distribute the 3, look what happens if I just divide by 3. Make that side less complicated. 27 divided by 3, well, that's 9. Then again, instead of doing x minus 5 times x minus 5, what if I just square root both sides? But what do you have to remember when you square root both sides? Plus or minus 3. So really I'm at x minus 5 could equal 3, or x minus 5 could equal negative 3. And then you've got 2 super simple equations to solve. And you have your 2 answers. You would have gotten the same thing if you went through all that work to multiply out the left-hand side, but this was much simpler. Last one, see if you can do F. Pause your video and try F. Okay, here we go. If all of it is under a square root, how do I undo a square root? Well, I do the opposite. I square both sides. 3x minus 4 equals, when you square something, it's always positive. 25. Add 4, I'm running out of space. If I add 4, I would get 29. Divide by 3, and x equals 29 over 3. Doesn't always work out perfectly. Decimals are a mess, so just leave it like that as a fraction. Okay, hopefully this all looked familiar to you, and I hope you're doing good.